What up, guys? How you doing today? Welcome back to Super Search's Classroom. And today we're going to discuss housing. What is housing, you say? And yes, I did draw this picture. Welcome back to Super Search's Classroom. Today we're going to discuss housing. You see this amazing picture? I know what you're saying. Wow, that's a beautiful house. I drew it, and it's amazing, right? But back to the video. Housing, what is housing? So a couple of years back, I was noticing that some kids were making mistakes with regrouping, and I've had to find a way to reduce that. So I haven't seen it anywhere else, but we started drawing vertical lines. And if I have, I'm sorry. You know, anybody out there that I offended, I don't want to say I stole your stuff. I always get credit where credit is due, right? But in this case, I needed to find a way to reduce errors, whether it was regrouping. And I came up with, drawing vertical lines, make sure each place value was separate from another place value. So 1 stayed in 1s, 10 stayed in 10s, because we had issues with regrouping. And so now I call it housing. Let's house it for everything where we're adding, standard algorithm, subtracting, multiplying, dividing. I just say, hey, let's house it. And it has reduced the number of errors significantly. That kids are like, oh my God, I don't make any mistakes. I get it right. So take out your pencil and paper, follow along, and let's get started. Let's house it. All right, guys, we're here. We're going to do several problems: an addition, a subtraction, a multiplication, and a division. And you're going to see why I always use the housing technique, or I house it, or why I always, in every video that you see, I use it, because it helps me reduce the errors, lets me get them all right. And that's basically the purpose of the housing. Why do I need to use it? Why should I use it? Well, you don't have to, but it's for you. If you want to make better grades, if you want to miss less problems, you want to get more problems correct, I suggest you do it. And so follow along with me again. Get your notes out, paper out, and you can even do your own problems and reduce the amount of errors using this technique. So let's do addition first. So I have, let's throw up some numbers. What number can we use? Let's use 423 plus 298. Okay, bam. So that's standard algorithm. So first thing I do is I house it, right? I'm gonna draw a vertical line between the ones place and the tens place. So between ones place and the tens place. And then I'm going to draw a vertical line between the tens place and the hundreds place. That lets me know what is what, right? So now I can get started. Once I do everything, once I annotate, I can go ahead and start. So I have 3 plus 8. What's 3 plus 8? So let's see. Let's add 3 to 8. 9, 10, 11. So 3 plus 8 is 11. And y'all didn't see me, but I was adding it with my fingers. And that's perfectly fine. Wherever you're at, that's fine. As long as you get it right. Hey, do it. Now we regroup. We're in the tens place now. So that 1 is not that digit 1 is not a 1. That digit 1 is actually worth 10, right? Because it's in the tens place. So we're going to go ahead and add 1 and 2, which makes it 3. And then I can add 3 and 9, which makes it what? Let's go ahead and count it. And use your fingers. Why not? So we start at 9 and we add 3, right? 10, 11, 12. So 3 plus 9 is 12. And again, we regroup it. Bam. And as you notice, I don't know if you can see, you notice I'm not putting the digit 1 over here again in the tens place because it has its own house. It has its own house. I'm not getting confused. And that's where usually it comes in, where we may put the same digit in a different place value, and that's what makes it where we get the errors, right? So let's go ahead and finish it. 1 plus 4, 5. 5 plus 2 is 7. Bam. So 423 plus 298 is 721. So that's our addition. Let's go ahead and go to subtraction. All right, we have subtraction. 48 minus 34. And this is a two-digit, subtracted by two-digit, right? So what do? Same thing. I draw a vertical line between the ones place and the tens place, right? Bam. So let's get started. We always do from right to left. When we're subtracting, we're adding, we're multiplying in standard algorithm. So 8 minus 4. 8 minus 4 is what? 4. And you can always take away 4 minus 8. So we can always count backwards. 7, 6, 5, 4, right? 4. Bam. And use your fingers. Why not? I know they don't want you to use your fingers at school, but hey, until you get there, use them. Let's get it right. And there's no need to borrow, no need to regroup. So we go ahead and go to the tens place and subtract 4 minus 3. And that is 1. So 48 minus 34 is 14. And you can go ahead and do your own problems as well later on. Practice putting the vertical line down. How's it between each place value? All right. And now let's go to a multiplication one. Bam. Let me make my pen smaller in just a second. And I do the same thing. I draw a vertical line down the middle between place value 1s and 10s. And then I go to the next one. Place value is what? 10s and 100s. And this is how I do multiplication. So let me change the pen up a little bit. So there we go. 7 times 5. Remember, the good thing about multiplying any number times 5, it's either going to end in 0 and 5. 0, 5, 10, 15. So the number is either going to be 0 or 5. So 7 times 5 is what? 35. And you can skip count on your fingers if you need to. Why not? So I know this. So we got 5, and we regroup. We put the 3 up here. Bam. So that 3 is actually worth a 30, right? Now we multiply 7 times 4. 7 times 4 is what? 28. Plus 3 is what? 31. So, bam. And then regrouped again. Right? Now, 7 times 3 is what? 21. Plus 3 is 24. Now you look down here in the partial product, we have 2,415. So I'm gonna go ahead and draw a line there, letting me know, oh, I'm at a thousands now, between the hundreds place and the thousands place. Bam, I do that. Now I go to the next problem. Now I see I have numbers here, so this is what I do when I'm multiplying using standard algorithm. I go ahead and scratch that out because I'm not going to need it anymore. I scratch the 7 out so I don't get confused. I don't need that anymore. Bam. And now I will multiply using the 2, which is in the tens place. So I was about to forget something. Put the placeholder. Why? Because the 2 is in the tens place. So put a placeholder. All right. So 2 times 5. Remember what I said, 5 either ends in 5 or in 0. So 2 times 5 is 10. There you go, 0, carry the 1. Now, because I scratched out, let me scratch it out a little bit better. I'm not using the 3 anymore, I'm using the 1. So 2 times 4 is 8, plus 1 is what? 9. There we go. Boom. Then I go to the next place value. So 2 times 3 is 6. Bam. And after multiplication comes addition. Right? 5 and 0. 5. 1 plus 0. 1. 4 plus 9. 13. We group. Bam. 1 and 2 is 3. 3 and 6 is 9. So 345 times 27 is 9,315. And boom, we're on it. We got 100, right? Because these little lines, these little vertical lines, they help a lot. I don't get confused anymore. And now let's finish off with division. All right. So we have 6,840 divided by 15. So like I said before in the previous video, you can check it out using division with standard algorithm, and I'll post a link down there. Let's do the multiples of 15, and we could go up to 6. I always go up to 6. So we have 15, 30, 45, 60, 75, 90. And that's 6, right? 1, 2, 3, 4, 5, 6. All right. And let's go ahead and so what do we do here? The same thing. We draw a vertical line that goes into the quotient and all the way down to separate our place values. So in this case, we're going to start with the thousands and the hundreds. We draw a line that separates the thousands and the hundreds. So bam, boom. Now we're going to draw a vertical line that separates the hundreds from the tens. Bam. And now we're going to draw a vertical line that separates the tens from the ones. Bam. All right. So now we can go ahead and divide. Can 15 go into 6? Remember, in division, you can only go into a number if it's the same number or close enough. It can never be greater. So the divisor cannot be greater. So nope, we cannot do that. Bam, bam. Ooh, let me change pens. Bam. So it cannot do that. And let me boom, boom. It cannot do that. So nope. So we go to the next place value. So can 15 go into 68? And let's see. 1, 2, 3, 4, 5. Oh, so 60. And I know this. Let's make it more 0. So 60. 15 can go into 68 4 times. 4 times, and 15 times 4, it's 60. Because 60 is the closest to it. We want a number that is exact or closest to it. Never over, right? Now we subtract. 8 minus 0 is 8. 6 minus 6 is 0. Now, can 15 go into 8? Nope. So we have to bring down. Bam. And that becomes 84. Can 15 go into 84? I think it can. Let's count. 15, 30, 45, 60, 75, 90. Oh, 90 is greater, and 75 is the closest enough. So how many multiples is that? 1, 2, 3, 4, 5. 5 multiples. Bam. Where is that? So 75. There we go. And look, by using it, I'm about to subtract, and it's going to help me out. 4 minus 5. Oh, we can't do that. We got to regroup. We got to borrow from our neighbor. Bam. And that becomes a 14. 14 minus 5 is 9. 7 minus 7 is 0. Now, can 15 go into 9? Nope. We have to bring down. And the 9 becomes a 90. 15 goes into 90 how many times? 1, 2, 3, 4, 5, 6. 6 exactly. Bam. 15 times 6 is 90. And we can go ahead and close it out. 0 minus 0 is 0. 9 minus 9 is 0. And that's why I love using this housing technique. It reduces on the errors. So you won't make that many mistakes. And I hope you liked the video. Give it a like. Thank you very much for watching. And practice on your own.